The Gauss-Seidel Method. It is an iterative technique for solving a square system of n linear equations with unknown x. The Gauss-Seidel Method, also known as the method of successive displacement, is an iterative method used to solve a linear system of equations. It is named after the German mathematician Carl Friedrich Gauss and Philipp Ludwig von Seidel, and is similar to the Jacobi method. The element-wise formula for the Gauss-Seidel method is extremely similar to that of the Jacobi method. The computation of x raised to k plus 1 uses only the elements of x raised to k plus 1 that have already been computed, and only the elements of x raised to k that have not yet to be advanced to the iteration k plus 1. This means that, unlike the Jacobi method, only one storage vector is required, as elements can be overwritten as they are computed, which can be advantageous for very large problems. Gauss-Seidel method is the same as SOR, or successive over-relaxation, with W is equal to 1.
Given the system of equation of 3x1 plus 7x2 plus 13x3 is equal to 76, then x1, 5x2, 3x3, 28, 12x1, 3x2 minus 5x3 is equal to 1. So we must first get this equation x1, x2, and x3. First, as x1, all the value transposed, so 76, change minus 7x2 minus 13x3 all over the value of our x1 is 3. Get along? 28 minus x1 minus 3x3 all over, but the value of x2 is 5. x3 also 1 minus 12x1 minus 3x2 over the value of 5. Now we go along to the iterations. Our first iterations of x1, x2, and x3 will be 0, because all the values don't have numbers. So first at x1, so we use on the calcu 76 minus 7 times x2 is 0, so 0 and 0, so we get the value of 76 divided by 3. So the value of our second iteration is 25.33. Now we have the value of x1, so the value of this will substitute to the second equation. So the 28 minus the value of 25.33 minus 3 times x3 is 0 divided by 5. We got the value of 0.534. So we have the value of x1, x2. Now these values will be substituted to the third equation. So 1 minus 12, 25.33 as x1 minus 3 times the value of x2, 0.534 divided by the negative 5. So we got 60.91. We go already to the third iteration, so we have the value of x1, x2, and x3. So as we all know, on the Gauss-Seidel, we must use only the latest values of this and this and this. So on our third iteration, all these values will be substituted to the first equation. So 76 minus 7 times the value of our latest 0.534 minus 13, the value latest value of x3, 60.91 divided by 3. So this is now our x1's latest value, 239.86. So as we go through again to the second iteration, just as we all do here, we must also do here. So 28 minus x1 negative 239.86 minus 3 times the value of x3, 60.91 divided by 5. So we have already the latest value of our x2, 17.03. So we have the latest x1 and x2. So as we all go through to the x3, so 1 minus 12 times the x1, negative 239.86 minus 3, the value of 17.03 divided by negative 5. So we have the value of negative 565.65. So as we go to the fourth and fifth iterations, we must all know that Gauss-Seidel is only using the latest values of the iterations. Thank you.